Hello everyone. I am privileged today to be the first presenter after the summer break. I hope you all had a really nice summer vacation and you are looking forward to hear something interesting today. But before we jump into the presentation, I would like to introduce myself. My name is Pavel Rabetski. I'm a software development consultant. I've been working here in Gothenburg in different companies for the last 7 years. Before that, I worked in Belarus, where I come from. Most of the time, I develop Java-based and JavaScript-based web applications, but I also worked with some infrastructure projects. And recently, I had a quite interesting test automation project at Telia company. And that's why the topic for today is reproducible component tests for microservices using Docker. The title is a bit long, but I tried to add as many buzzwords as possible so many people come. So to start with, let's talk about component tests. So basically, when we talk about component tests, it's we verify behavior with this test of a component, so it's a functional test. And by component, we mean a logical part of application. So for example, if we have an accounting application, a component can be a module that calculates taxes for us. So why do we bother implementing component tests? Why not just testing the entire system, implement system tests? The first reason is that it's cheaper. We do not have to wire the entire context. We have less dependencies. So it's cheaper to implement and cheaper to maintain, actually, because if you think of a system test, when you change one of the components, you have to change your system tests usually. But that does not apply for component tests. They're independent, those tests. Another reason is that it's easier to locate problems. For example, if your component test fails, you usually know exactly what behavior in the component is broken. So it's cheaper to fix problems when you encounter them. So let's now think about component testing in terms of monolithic application versus microservices application. So when we talk about components in monolithic application, they have the same life cycle. What I mean by that is when you ship application into production, you do not ship a separate component. You make a bundle and then you ship the whole bundle into production. They also share runtime or environment, so they are homogeneous in terms of infrastructure. And they are somewhat gray box. We have more possibilities to see the internal structure of the component and hack it a little bit in terms of testing. We can mock interactions with other components easier. But when we talk about component testing in terms of microservices architecture, components have different life cycles. We usually want to ship a component independently from other components, and we want to make sure that the whole system is still functioning correctly. And they can also have completely different runtimes and environments. So they are heterogeneous in terms of infrastructure. They can be heterogeneous in terms of infrastructure. And from a testing perspective, this is kind of a black box. We cannot really trick something or look inside the component. Usually it's behavior and state exposed through some REST API or something like this. But nevertheless, component testing is even more important for microservices architecture, but at the same time, it's a bit more complex to implement it. So how do we test our components, our microservice? So So this is a simplified sort of visualization. So we have a microservice that we start in some test environment, and then we run a test script against it. And when we say microservice, it's usually some sort of a stateful component. So it can be like a web application with a database that persists its state when we interact with it. And test environment provides necessary resources for our microservice. It can be some queues, and it can be some other services that this microservice interacts with, or mocks of these services. And let's look into the test script. And let's say our test script contains 3 tests: test 1, test 2, and test 3. And since our component is a stateful component, after each interaction it changes its state. So after first test, it will change the state from S0 to S1. And so does it for other tests. So what happens if we, for example, want to apply these tests in sequence? What happens if we run test 1 and after that test 2? After running test 1, our component goes to state S1, but we actually don't know whether test 2 will bring our component from test 1 to test 2. We are not sure. We know if it's in state 0 in the initial state, but not when it's in state S1. And same applies when we repeat the same test over and over again. So reproduce the same test is not a trivial job. So how do we approach this problem? To my experience, there are 2 main approaches to this problem. The first one is we try to clean up or reset the state after each test. So basically, when we apply test 1, we run test 1 against the system. After that, we run some cleanup code that will reset the state to the initial one. And so does each test. What it means? It means that we have an extra development effort. We have to track what entities we have created, and then we have to clean up them. It also means that it's not always possible. Our system can be implemented in a way that there is no pure reverse function. So if, for example, if we add an entity to the database through a REST API, and then we try to make a delete request that we assume will delete entity. In reality, only a property deleted is marked to true. So we do not really go back to the initial state. And that can be an issue. What are the other approaches? Another approach could be we try to separate contexts of tests. We want to make them fully independent, which means in whatever state Sx we are, if we apply test n, it will always go to state Sn. An example could be if we have a system that manages, for example, user accounts. We always, for each test, we generate a unique user ID. And by that, we make sure that they will not collide with each other, those tests. But it also means extra development effort. We need to make sure that those IDs are unique, and it can be many IDs of entities that dependent on each other. So we need to keep track of this unique context. It is also not always possible, as in previous example. Let's say you have a global resource that is shared by all users, and it can be, for example, a bandwidth. So bandwidth is a global resource. So you cannot separate contexts in this case. You have to share this utility among all the tests. Or, for example, you have a complex pre-generated data with a limited amount of entities. So, for example, you have a very complex database set up, and you pre-generate this data, and you have only 2 users. So you have to share those 2 users when you run tests. Do we have other options? We actually could do something like this. We could recreate the entire test environment for each test. So basically, each test runs against a unique test environment, and they are independent of each other. So this approach would have clear benefits compared to the previous approaches. We definitely have less development effort, because now we do not need to separate context or clean up after ourselves. We just shut down the entire environment, that's it. We also have no constraints from the previous methods, like even if we have a global resource in our microservice, it doesn't matter, it's not shared across the tests. However, if you would offer this approach to me in terms of monolithic application and running on VirtualBox or dedicated server, I would probably say that you are out of your mind, because it will be deadly slow and likely to be very complex to do. However, if we would think of this approach in terms of a microservice running on Docker, then this approach becomes much simpler. So basically, microservice is much faster to start usually, and Docker is much easier to manage in terms of infrastructure. If some of you guys not familiar with Docker, this is not the main focus in this presentation. There is a lot of resources available online that will describe what Docker is, but shortly I would say Docker is a much more lightweight alternative to classical virtualization. It's a software containerization platform that will pack your software in a container that is easy to ship everywhere. So, and this is what Docker Bay library does. This library is a Java library for component testing. It orchestrates Docker environment for you to run your component tests against unique environments. And underneath it is based on JUnit and Docker Java client. It's available on GitHub under Apache 2.0 license. So you can have a look. So let's go through an example how to use it with an example of a hotel booking web application. So let's say we have an application, a simple microservice for booking hotels and managing hotels. And we have some external service that we use. So this service will return reviews about these hotels. And we persist our state in some sort of database. And let's say we have containerized all the components of our architecture. So we have containers with the web app, with the DB, and with the service that we depend on. So first thing obviously what you need to do is to add dependency of this library, Docker Bay library. So this is pretty straightforward. And now we just describe the environment that we want to run test against. This we do with the help of JUnit rule that will wire the environment before each test and shut it down after each test. And in the environment we say what Docker containers we want. And here we want 3 Docker containers. As a database we use Postgres, so here it says Postgres container, but this is actually, on the picture it was a database. And as an external service here, this is review smoke container, which is the second one. And the web app container is the actual web interface and application. So how do we describe each container? So this is an example of how we describe, for example, Postgres container. We tell what image we build this container from. We give it some name. And this name is important in terms of locating other containers. So basically, in the test environment, this will be the name, the DNS name of this service. So all other containers running in this unique environment will be able to access this container with this name, http://Postgres. And then we also want to wait before we continue that the database is ready, and that what next invocation does, wait for log entry. So we wait for this entry in the log of this container. So how does web app container looks like? This is a little bit more complex because apart from image name, container name, and that we wait for this URL, we also expose TCP port. When we do that, the library will find a random port on localhost and map it to the container port. So by doing that, we avoid port collisions. And this is reviews mock container. We run wire mock actually to mock this service. So that's why container name is wire mock version 2.1.11. We give it a name reviews mock, and we also add some command. When we start wire mock, this will be added to the start command. So the wire mock actually will start inside the container on port 8083. And then we add tests, basically, like you would add any JUnit test. So here we have 3 tests for our web application. First, we'll test that we should get a hotel, if it exists, with reviews. So it means that it should ask this external service and return hotel information with reviews. Second test will be that we should be able to update hotel information. And the last one, that we should be able to delete hotel. And this is how test can look like. The request specification object is from JWay REST Assured. So it's a REST Assured API. If you have worked with it, then it will be easier for you to understand what's happening here. But basically, in the test, first thing we do is we create dummy hotel. We do it by posting against API hotels this JSON content. So basically, by doing that, we know that the hotel is created. And then we update this hotel address of this hotel. We do this by making put request against API hotels/ID with this JSON body. And at the end, we want to validate that address is updated. So basically, we get this hotel, and we validate, we assert that in the body, address property contains updated address. Next test, a little bit more complex. This test tests that we get hotel with reviews. So first step is the same. We create dummy hotel. This is simple. But then we talk to actually wire mock service that is also running in the container. And we tell wire mock that when you get this request, IP reviews with hotel ID 1, please respond with status 200 with the content type application JSON and with this JSON body. I hide the body actually because it was too long. And at the end, we need to validate that when we get hotel, we actually receive a response with status 200 and with the name dummy hotel, and inside reviews we have a non-empty array. So what happens under the hood when Docker Bay interacts with Docker host? Under white area, it's a sort of command line interface. So we'll see some Docker commands to understand how the environment looks like after each step. So the first step when you have configured this library is it will go through all your containers, extract image names, and will try to pull it. In our case, it's like wiremock container and Postgres container, and as you can see, if we run after this step, Docker images, you will see like 4, because our demo web app container, or image, sorry, is based on Java image, so we pull Java image first, and then we build demo web app container. And you also see Postgres container and wiremock container. Well, I'm sorry, images. We talk about images now, yeah. So this is the first step. The second step is it will create a unique network with a unique ID. If you run docker network ls command after this step, you will see that a network with this unique ID is created, and in this case, unique ID is our test class name plus method name of the test. Then we create and start containers, and this is a bit more complex step because the containers are started with the same unique ID prefix that we have for network. So the name of the containers here, you can see that they are prefixed with class name, method name, because Docker does not allow to start containers with the same name. So we need to separate it and make sure that they are unique. And then it will start those containers inside the network. And inside the network, DNS names of the containers will be just simple names: web app, Postgres, and this reviews mock. Another thing that is important here is, as you can see, the random port is allocated. So when we build the container and we say we want to expose TCP port, we allocate a random port on localhost and map it to the port inside the container, so that we have an access from outside the Docker environment into this network. And then we actually execute the test against this environment. That's what we saw previously. After we run the test, and whether it is successful or not, doesn't matter, we shut down the environment. We clean up after ourselves. And this is what library does for you. It will stop and remove containers. So after this step, if you would run docker ps command, you will see nothing. It's empty. And delete the network. So it's clean. So after you run docker network ls command, you will see the default networks only. So next time when you run the same test, the result will be the same. You can repeat this test, it will wire the environment. You will repeat this test, it will shut down the environment. You can repeat it as many times as you want without worrying that the component has changed its state. So this unique environment allows us also to parallelize things. So basically, one Docker Hub allows us to start many containers and many networks, which means we can run those threads, those tests in 3 different threads. And we will simultaneously start wiring the environment, starting Docker containers inside each environment, running tests, and then shutting it down. Although this library does not do parallelization on its own, but you have a possibility to do that by running, for example, failsafe plugin. Here is an example of configuration to run 3 threads in parallel. So you will be able actually to parallelize test execution through an additional plugin that you can use. In the future, probably it will be good to run to be able to run against several Docker hosts, so you will have a true parallelization. And in this case, obviously, this library will have to do the parallelization itself. I think I was a little bit too fast today. So if you have any questions, yes?
So you say when it's done, even if it failed or succeeded, it destroys the environment?
Yes.
What if you need to debug, for example, to find out why it failed?
Yeah, you can debug it as you would debug JUnit test. If you you can set a breakpoint just in the first line. You put a breakpoint and you just debug it in your IDE. And when it reaches this first line, all the environment is wired. So it's up. So then you can go through each step and investigate inside Docker containers what's happening. So it's possible. Maybe it's
You have to run the test again?
Yes. Basically, yeah. You will have to start it again. Yes?
Does it transfer the logs somewhere before it goes down?
Yes, you have a possibility to print out logs. So there is a method, if I remember correctly, print. It basically says print logs. And before shutting down this container, it will print log from this container, basically. But if you, for example, write all the logs inside a log file in the container, that will be more problematic because the container on its own will not produce any logs for you. Yes?
So if you run a unit test, which usually takes less than 10 milliseconds, how much time for running Docker as well?
I have a demo project also available on GitHub, which runs with this library 3 tests that I showed today. So basically all the code that I showed you can play with on GitHub. For this particular case, it takes 1 minute on Amazon micro instance. So, and I don't do parallelization. But if you have a powerful machine with many processors, many cores, powerful processor, then it can. It depends also. I cannot answer this question. Obviously, it will be much longer than a simple JUnit test, but it depends on your service. How long time does it take to start, and how many Docker containers you need to test this service. Because if you have many dependencies, for example, if you have a microservice that depends on 4 other microservices, and you have to start mocks for those services as well, then it might take longer time. But obviously, we are not talking about hours, we are talking about minutes. Yes? The question was if we consider to use Docker Compose. We haven't tried with Docker Compose. I'm not sure if it's. I'm not a full expert in Docker, but I'm not sure if Docker Compose is the recommended way to do that to wire containers anymore. But we didn't do it with Docker Compose. Never tried with it. This works pretty well for us, so we never needed any other method of doing this.